Good afternoon, everyone. So, welcome to Career Launcher. My name is Naveen, and today we will continue with our series of Target 99 plus percentile in CAT 2025. This is LRDI Basics Part 13 of this series of LRDI. So, as usual, we'll be looking at some new type of LR, wherein those are going to contain numbers. So such types of sets are called analytical reasoning. So there are certain types of calculations that are required, which are not completely logical, but they do have a bit of tint of logic involved. But the major part consists of calculation. So Prime Hotels is a hotel chain. Four of its hotels are located at the heart of the commercial hub of metropolitan cities New Delhi, Mumbai, Chennai, and Kolkata. As it is a luxury hotel located in the city center, there are not many rooms, only 12 in any of the prime hotels. As the name suggests, all the rooms in each of the hotels of the hotel chain are numbered as prime numbers. All the hotels have two floors and an unequal number of rooms and an equal number of rooms on each of the two floors. The ground floor room numbers are chosen from the numbers between 1 and 100, and the first floor room numbers are chosen from numbers between 100 and 200. So this question is completely based on prime numbers from 1 to 200. As per norms, the room numbers on the first floor are 100 more than the corresponding room numbers on the ground floor. The following conditions were followed at the time of the construction of the hotels. The 10th digit of the room numbers of any two rooms on a particular floor cannot be the same. The average number of all the room numbers put together on any floor is a natural number. The combination of all the room numbers available in the four hotels located in different metropolitan cities is not the same. So basically, we have got two floors in four metropolitan cities. So two floored hotels in four metropolitan cities, where in the ground floor, whichever prime number we have, they are from 1 to 100. And in the first floor, we have the prime numbers from 100 to 200, wherein the first floor room number is exactly 100 more than the prime number that we have on the ground floor. Okay, and then we have got these three conditions that 10 digits should be unique for every hotel. The average number of all the room numbers put together on each floor is a natural number. The combination of all the room numbers available in the four hotels located in different metropolitan cities is not the same. Let's look at the questions before we proceed in order to understand to what extent we have to figure out everything. So the first question is, if the average of the room numbers on the ground floor of the prime hotel located in Chennai is a perfect square, then what is the average? If the average of the room numbers on the ground floor and the first floor taken together of the prime hotel located in New Delhi is a perfect square, then what is that particular average? So basically, there are obviously going to be cases, at least 4 cases, because we have got 4 such hotels. If they're talking about Chennai could be one of those 4 cases. Out of those, we need to figure out, if it's a perfect square, is the average is the perfect square. So which perfect square could that be? Same goes for New Delhi. Since all the questions are theta questions, so which means even though there are going to be cases, we will still be able to figure out which combination they are talking about. Okay, so let's write down, think about all the prime numbers between 1 to 100, and then this, when we add 100 to it, we will end up getting a prime number between 100 and 200. That should be a prime number as well, right? So the first prime number we have is 2. 2 plus 100 is not a prime number. 3 plus 100 is 103. So that is a prime number. 5 and 105. No, 105 is not a prime number. Then we have got 7. 7 and 107. Yes. 9 is not a prime number, though 109 is. 11 is a prime number, 111 is not. 13 is a prime number, 113 is going to be a prime number as well. So 13 and 113. Next is 17 is a prime number. 117 is not. It's divisible by 3. 19 is a prime number. 119 is not because it's divisible by 7. So If the tens digit is 0, we have got two cases. If the tens digit is 1, we have got one case. Let's look at in 120s and 20s. 23 is a prime number. 123 is not. It's divisible by 3. 29 is a prime number. 129 is not. It's again divisible by 3. So no prime number in 20s. Let's look into 30s. 31 is a prime number, and so is 131. Okay, after 31, we have got 37. 37 is a prime number, and so does 137. In 40s, 41 is a prime number, 141 is not, divisible by 3. 43 is a prime number, 143 is not, divisible by 11. 47 is a prime number, 147 is not, again divisible by 3. So nothing in 140s. 50s. 53 is a prime number, 153 is not, divisible by 3. 59 is a prime number, 159 is not, again divisible by 3. Let's look into 60s. 61 is a prime number, 161 is also a prime number. No, 161 is divisible by 7, right? So 161 is not. 67 is a prime number. 167 is also a prime number. It's not divisible by 2, 3, 5, 7, 11. So 67 and 167. So only one in 60s. In 70s now, 71 is a prime number, 171 is not, divisible by 3. 73 is a prime number, 173 is also going to be a prime number. Looks like yes, it's going to be. So 73 and 173. 79 is a prime number, 179. What about that? So 179 square root is going to be 12 point something, so 13 point something. So we need to divide it by all the prime numbers up to 13, not divisible by 2. 179 is not divisible by 3, it's not divisible by 5, it's not divisible by 7, it's not divisible by 11, it's not divisible by 30. So 79 and 179. In 80s, 83 is a prime number, 183 is not, divisible by 3. 89 is a prime number, 189 is not, divisible by 3 again. In 90s, we have got only one prime number, which is 97, and 197 is not divisible by any prime number up to 30. So 97 and 197. Okay. Now, we are done with the first condition, that the tens digit of the room numbers of any two rooms on a particular floor cannot be the same, right? So there are 6 floors and we have got, we have got 6 rooms and we have got a couple of floors. The average number of all the room numbers put together on any floor is a natural number. This is something we will solve and we will look into every time we solve the question. The combination of all the room numbers available in 4 hotels located in different metropolitan cities is not the same. As of now, if we look at the first room number, there are 2 possibilities. Third one has got 2 and the sixth one has got 2. So basically 8 combinations, or these can be allotted to 8 different cities. Let's look at the questions now. So the first question is, if the average of the room numbers on the ground floor of the prime hotel located in Chennai is a perfect square, then what is that particular average? So let's consider that the average of all the room numbers in a particular floor is a natural number. Since we need the average, so that would mean we need to divide it by 6. So I'm going to see that every number, how does it perform when divided by 6? So 3 is of the form 6k plus 3, 7 is of the form 6k plus 1, 13 is of the form 6k plus 1, 31 as well, 37 as well, 67 as well, 73 as well, 79 as well, and 96 plus 1 is 97. So this is also. So we can see that every number is of the form 6k plus 1 except for the first one, which is 6k plus 3. If we want this to be divisible by 6, we cannot take this, which means 3 and 103 are definitely not the room numbers in any of the hotels. So the 4 combinations exist. For the third room, there are 2 possibilities, and for the sixth room, there are 2 possibilities. So overall, 2 into 2, 4 possibilities for a total of total of 4 metropolitan cities. Now, since this is known, now we are told that the average of the room numbers on the ground floor of the prime hotel located in Chennai is a perfect square. So we need a perfect square combo. So 7 is fixed, 13 is fixed. We have got 31 or 37. 67 is fixed. We have got 73 or 79, and 97 is fixed. So the values that are fixed, let's pay attention to those. So 7 plus 13 is 20. 67 plus 97, this is going to give us 164. So we have a total of 184 right now. Now, if you look at 31 and 73, those are the 2 smallest numbers here. Instead of 31, if I take 37, it will increase by 6. Or instead of 73, if I take 79, that will also increase by 6. So whatever sum I will take by taking 31 and 73, they will further increase by 6. To what extent? If 31 becomes 37, that's an increase of 6. And if 73 becomes 79, that's another increase of 6. यानी कि maximum 12 बढ़ा सकते हैं from the smallest values. So let's pick 31 and 73. This is going to be another 104. So this turns out to be 288. Now, it could be 288, or we can add 6 to it, which is going to give us 294, or we can again add 6 to it. So if these are the different sums possible, so if we divide it by 6, this is going to give us 48, this is 49, and this is 50. So 49 is the only perfect square we can have as the average of the room numbers for Chennai. Okay, next one. If the average of the room numbers on the ground floor and the first floor taken together of the prime hotel located in New Delhi is a perfect square, then what is that particular average? So as of now, we already know that 103 and 3, they are not permitted, right? So the sum that we can have for the ground floor is going to be 288, 294, or 300, the one we have already seen. Now, we do not have to add for first floor. We know that every room number increases by 100. So that would mean here 6 rooms will increase by 100. So we will have 888 plus 600 is 894 plus 600 is 1200. Sorry, 900. So that would mean that our sum, when added and then divided by 6, should be a perfect square again. So basically, if I look at the first combo, what we will see is 288 plus 888 divided by 6. Sorry, not 6, not 12. It's 12 now, right? So 288 divided by 12, it's going to be, we would already know that this is 12 into 2 is 24, and 12 into 4 is 48. Now, since we have got extra 600 in the next one, which divided by 12, which will give us 50. So 50 plus 24 is going to give us 74. This will change to 98. If I do the same thing with 294 plus, instead of 894, we can write 294 plus 600. The same thing that we did previously. So 294 by 12, it's going to be 294 plus 294 basically. So this is going to be 49 plus 50, which is going to give us 99, which is again not a perfect square. So basically 900 plus 300, it's 1200 divided by 12 will be 100, which is a perfect square. Well, we should not worry much about this because it's a theta question. If somewhere, if we think that we have made a mistake, we will come back to it if we do not get an answer. If we're able to get an answer, that has to be a unique case, right? Okay, next. What is the average of all the room numbers of the prime hotel chain across the country? So we have already seen, we just saw that we are going to have a 98, we are going to have two 99s, and then we are going to have 100. So the average of all of this is going to be 99. Now, you may think that why we are going to have two 99s. Well, if you remember, for the ground floor, the sum was 288. We could either increase this by 6, making it 294, or we can increase this by 6, making it another 294. And if we happen to increase 6 in both, that will increase by 12, making it 300. So when I add 600 to each of them, because the first floor room numbers are 100 more than what we have, so we are going to have these 6 cases, so these 4 cases, right? So this is going to give us an average of 98. This one was 99. Another will also be 99, and this will be 100. So the average of all these 4 will be the middle value, which is 99. Okay. Next one. The Prime Hotels chain wishes to start a new hotel in Bangalore on the same lines as its chain of 4 hotels that will have one extra room on each floor for the founder and co-founder of the hotel chain. To fulfill this purpose, conditions 1 and 2 are not followed at the time of the construction of the hotel. So what were the 2 conditions, the first and second? The first one was the 10th digit of the room numbers of any 2 rooms on a particular floor cannot be the same. So this should be removed. Second, the average number of all the room numbers put together on any floor is a natural number. Again, not allowed. So the only condition permitted is the combination of all the room numbers available in the 4 hotels located in different metropolitan cities is not the same. So all the 4 cases we have seen previously, this one should be a new one, right? There is a new condition though, that the average of the new room number added on each floor is a prime number. What is the average of the new room numbers added at the hotel in Bangalore? Well, basically the 2 numbers that we were discarding because of the first and second condition, these 2 new room numbers will be included now. Why? Because if we want first floor room numbers to be 100 more than the room numbers of the ground floor, and they both should end in prime numbers, this is the only pair of prime numbers that is left. Every other pairs we are done with. So 3 and 100 are the room numbers that were added to ground floor and first floor respectively, of course. So the question asked is, what is the average of the new room numbers added? So basically 3 and 103 average, which is going to give us 53. And done. So the initial part that took us some time was to figure out P and P plus 100, they both are prime numbers, where P is a prime number less than 100, right? The second part was to see if the numbers are, averaging out and giving us a natural number, right? That was one tricky part, calculative. And the third one was to understand that you do not have to make all the cases. You just pick up the smallest of the values, find the sum or the average, see the changes that are being brought in if you make multiple cases, and then continue with it, right? Well, I hope you found this set to be a difficult one initially, but it turned out to be not so difficult. I would call this a moderate set. Okay. So thank you for watching. Please subscribe to the channel if you haven't. Like this video and share it with your friends. Thank you. Thank you for joining. I'll see you again very soon with another session. Until then, take care.